Now from Fourier series, let us have one simple, very simple example to understand the basic process how to determine coefficients in case of Fourier series and how to solve this example. Style is same in Fourier series. There are two forms as we know that one is trigonometric form and one is exponential form. So first one we are taking one small example of trigonometric form. Now here what is the function given? M of t is equal to t. So it is a simple ramp function whose amplitude is 1 here. Peak amplitude is 1. So there is no question that scaling will be by some other figure. So and the duration is 0 to 1, then 1 to 2, then 2 to 3. So if we look at the signal trace, then we can see that fundamental period is 1, 0 to 1, that is 1. For one cycle it is taking 1 unit time. That's why first thing in Fourier series is to take the fundamental period. So that is t is equal to 1. And now omega. Omega is, we know that 2 pi f. That is nothing but 2 pi by t. So 2 pi by 1. And therefore omega is equal to 2 pi. So this very first step is over. In case of Fourier series, very first step is to determine fundamental period, that is capital T or T0 we can call. Then second thing is determine omega. So these two things for this example we have first of all stated. Now let us have the calculation part. So very first is first coefficient, that is A0. A0 is equal to, what is our formula? 1 upon capital T0 integration over one period, that is T0, small t0 to small t0 plus capital T0, that is over one period, m of t or x of t dt. Now for this example, what is 1 upon t0? What is t0? T0 is nothing but fundamental period 1. So therefore we have taken 1 upon 1, that is 1. Integration over one period. So 0, small t0 is suppose this specimen we are taking. Any one you can take. You can take 1 to 2 or 2 to 3 or 0 to -1, whatever you want to take. But very simple logic is, if one of the limit we can select as 0, then our calculation part is going to become simple. So if our sample signal portion indicating over one period trace. So if it is possible to take including 0 as one of the limit, then that whole exercise becomes simpler. So that's why I am taking this particular sample over the interval 0 to 1. And that's why I have substituted small t0 as 0, and this is 0 plus 1. That is capital T0 is 1, and therefore it is 0 to 1. What is integration of t dt? Integration of x is x square by 2. So integration of t is t square by 2 over the interval 0 to 1. So upper limit is 1, lower limit is 0. Upper limit 1, 1 square divided by 2, that is 1 by 2, minus lower limit is 0. Therefore answer is 1 by 2. A0 is 1 by 2. Now for an, what is the formula for Fourier series? An, trigonometric decomposition. So an is 2 upon fundamental period, that is t, over the interval same t0 to t0 plus t, m of t cos of n omega 0 t dt. Now here 2 upon fundamental period is 1, so therefore only it is 2. Limit is 0 to 1. This t, m of t, what is m of t? It is t, so therefore that t is coming here. And cos of n, what is omega? Omega we have calculated here in the beginning of example. What is omega? Omega is 2 pi. So therefore here we have written 2 pi. So that is cos n 2 pi t dt. So what is the overall expression? T into cos n 2 pi t dt. Now we want to use the formula integration x cos ax. What is the formula? 1 upon a square into bracket cos ax plus ax sin ax. So we have taken here 2 into bracket 1 upon 2 pi n square into bracket, that is a is our here cos ax. So a is n2 pi. Instead of x now it is t. So a is n2 pi. So here it is 1 upon a square. That means 1 upon 2 pi n square into bracket cos ax, cos 2 pi nt plus a. A is 2 pi n. So 2 pi n. X is t. And sin ax, that is sin 2 pi nt over the interval 0 to 1. Now same thing, we have written the terms in the proper manner to this 2 upon 2 pi n square cos of 2 pi n plus 2 pi n sine 2 pi n. Upper limit 1 we have substituted for t and the lower limit is 0. So here it is into t, therefore 0 cos 0, and here it is t into something, so therefore that term is 0, and therefore first term upper limit both the terms are present. When you put lower limit, only first term cos of 0 is coming, and the second term since it is 2 pi nt, t is coming in multiplying, and when we put t is equal to 0, so this second term whole term will become 0, and that's why cos 0, whenever we put 0 in the first term, so that is 0. Minus sign is when we substitute the limit, lower limit, that is in between minus sign, and then cos 0, and the second term since this is 0, therefore 0. So overall it is coming out to be this term will become cos of 2 pi n is equal to 1, sine 2 pi n is 0, as we know that, and therefore 2 upon 2 pi n square cos 2 pi n we have substituted 1 plus 2 pi n into sine 2 pi n, that is 0, therefore it is 0. This is cos 0 is minus 1, and this is 0. So therefore overall it is coming out to be 0. An is equal to 0. And now when we calculate for Bn, same fashion, m of t sin n omega 0 t dt, t into sin 2 pi n t dt. Only difference is there we have used formula x cos ax. Here we are using formula x sin ax. So it is 1 upon a square sin ax minus ax cos ax. So accordingly, we have written this 2 into 1 upon 2 pi n square sin ax minus 2 pi n x cos ax. Upper limit 1 we have to substitute. See here carefully, upper limit 1 we are substituting, 1 here also 1, and when we put lower limit, that is cos of 0, and the second term is multiplied by t, that is 0. So if we know that sin 2 pi n is 0 minus 2 pi n cos 2 pi n. Cos 2 pi n is 1. So therefore 2 pi n into 1. Then sin 0 is also 0. And next term, last term is when we put lower limit, that is also 0. So this lower limit when we substitute here and here, sin 0 and 0. So both these terms are not contributing. This term is also not contributing. Only this term is going to give you 2 pi n into 1, and therefore Bn is this 2 pi n, 2 pi n, 2 will get cancelled, 1 will get cancelled. Resultant is coming out to be minus 1 upon pi n. Now our decomposition will be m of t is equal to a0 is 1 by 2 minus this minus sign is of this minus 1 pi n. So therefore an term is already 0 and bn term is bn into sine omega 0 n omega 0 t. So it is bn into sine 2 pi n t. If we expand, then few terms you can write in the decomposition form. If we want to find out magnitude, then S0 is nothing but A0, that is 1 by 2. Sn is equal to square root of an square plus bn square. Out of that an is 0 and therefore bn only. So 1 minus 1 upon pi n square, that is pi n square, and its square root. Therefore it is coming out to be 1 upon pi n. You can see carefully. You can pause the video and see carefully. So it is 1 upon pi n. And phi n is minus tan inverse of bn by an. So bn is minus 1 upon pi n and an is 0. So that's why it is coming out to be minus tan inverse of infinity, and that is nothing but pi by 2. So magnitude wise, the phase magnitude wise value is 1 upon pi n and phase value is pi by 2. You can plot the spectrum as well. So this way you have to find out A0, A and Bn, and then you can find out magnitude as well as phase.